Hello, this is Maria from mathmammoth.com. In this lesson, we're going to look at linear functions and the rate of change. First of all, I have here a simple definition for a linear function, and that is, if the graph of a function consists of points that fall on a single line, then it is a linear function. The word linear in that actually comes from the word line. And we will see another definition for a linear function later, but for now this is sufficient. I have here a table that defines a function. The input and output values in the table define a function. Notice the patterns here. In the inputs we have the numbers increasing by 2's. The x values increase by 2's. And the corresponding y values, or the outputs, increase by 1's. So that also indicates to us that it's a linear function when these increases are consistently the same. Now I'll show you the graph. And here's the graph of this function. We have 0, 2, 2, 3, 4, 4, and so on. The points fall as if on a line. It is a linear function. And now we're going to look at the rate of change for this function. But first, the definition. What is the rate of change? Let's read it here. The rate of change of a function is the rate at which the output values change as compared to the change in the input values. And we calculate it as the ratio of the change in output values divided by the change in input values. It's just a simple ratio. It's going to be either a number or a rate with units. And in the context of this graph, we will look at the difference in y values and the difference in x values. Going back to this graph and the table of values. So how do these output values change in relation to the change in the input values? We look at the difference in the output values. The difference here, the difference here, the difference here. It was just 1 every time. And the difference here was 2 every time. Okay? And the ratio of those is the rate of change. It was the change in the output values over the change in the input values, like that. So the rate of change here is 1/2. In the graph, you can take any 2 points you want. So let's say that I take this point and this point, and I look at the difference in the y values. So this is 6 and 3. 6 and 3. So the difference is 3. And then in the x values, 8 and 2. The difference in x values is 6. 3/6, which is the same as 1/2. And people often do this kind of thingy. They draw a triangle, or actually 2 lines, but with this it would be a triangle. And look at this here, the difference in y values, this here, and then the difference in the x values, this here. Now let's calculate the rate of change for these 2 functions here. And they are both linear functions. Input t is time and output is money values. Okay, so we will take the ratio of the change in the output values versus the change in the input values. The output values from here to here, they change by $10. Well, each time they do. And then in the input values, the change is from here to here, 5 minutes. Also from here to here would be the same, 5 minutes. So $10 over 5 minutes is the rate of change. This simplifies though. 10 divided by 5 is 2. So it becomes 2. And there's dollars per minute. So $2 per minute. Maybe it is the cost of using something over time. And this other one, inputs are time in seconds. Output is liters. And notice that the liters, these amounts are decreasing. And like I said earlier, I can look at any 2 values here. So I could look at the difference between this and this value, and the difference between this and this value. The outputs versus the inputs. So in the output, there's a decrease of 100 liters. So I will mark it as negative, minus 100 liters. And then in the inputs, it goes from 10 to 60. So there's 50 seconds. The difference is 50 seconds. And again, this one simplifies. 100 divided by 50 would be 2. It's negative though. Minus 2 liters per second. So that's actually a rate. Maybe you have a volume of water somewhere in some container or some tank, and it is decreasing that fast, 2 liters per second. Okay, being negative, it is decreasing. What is the rate of change of this function? Here we see a graph of a function. We don't see the function itself. We are not given it as a list of input-output values. We see its graph, but we can get the rate of change from here too. For that, I want to choose 2 points, and it's the easiest if I choose points that are exactly at grid lines. Like, let's say that one and that one. Let's call them A and B. A is -3, -2. B is -1, 1. So now, once again, I look at the change in the y values over the change in the x values, or the change in the outputs versus the change in the inputs. So the outputs are these numbers. From A to B, how did they change? From -2 to 1, the change is 3, a +3. And then over here, in the inputs, the change is 2. 3/2 is the rate of change. We can also see it from the graph this way. Draw a triangle and look at this here. This here is 3 units. This here is 2 units. Later on, you will learn this concept as the slope of a line. And in that context, we call these as the rise and the run. Lastly, let's say that I have some debt and I am paying it off in the same increments each time period. So that will produce a linear function. And let's say that my debt is so much at first, and I will pay it off in 5 months. My debt will be 0 at 5 months. I'll draw a line now. Not a perfect line, but anyway, let's say that my debt was, say, 3,000. So what is the rate of change of this function? Like I said, we could take any 2 points on the line and then look at the change in the outputs versus change in the inputs. But since I drew it a little sloppy, I'm going to just take this point and this point that I know for sure. 0, 3,000 is my first point. My second point is 5, 0. Let's write them here. All right, so we look at how the outputs change and how the inputs change. The outputs go down to 0. So that's a negative change, right? This is a unit, so I'm going to add it here, dollars. And the ratio to how the inputs change, well, they go from 0 to 5, and that is months. This one now simplifies to, okay, 3,000 over 5 is 600, but it's negative and it's dollars, negative $600 per month. So my debt is decreasing at $600 each month. That is the rate of change. Okay, this is all for this lesson. I hope it was helpful.